Hey everybody, this is Hydraulic 160 here. You may know me for my interest in clocks, elevators, and buses. But what all my friends at school know, as well as on Discord, is my major interest in smoke alarms. And as you know, there are two different types of sensing methods. One of them is ionization, and the other is photoelectric. We're going to be focusing on ionization and what type of element it uses for detection. And if you guessed Americium, well, you're right. By the way, this is my first school project vid, as well as my first scripted video. So please let me know if you want more videos in this type of style. So with all that being said, welcome to the first and last episode of All About Ionization, Americium. To give you a more in-depth observation, we'll go over its structure first. Americium has a total of 95 protons, 148 neutrons, and 95 electrons in its structure. Here's a Bohr model to help you. Or if you're a Lewis fan, no, not Lewis and Clark, this is chemistry here. Sorry about that. Here's the Lewis dot model as well. So, we know that Americium can ionize the air, but here are some other properties that you maybe didn't know about. Americium has a melting point of 2,149 degrees Fahrenheit. And for all you international viewers, that's 1,176 degrees Celsius. So your smoke alarm can survive in the scorching deserts of Egypt or underwater.
No, that's not what I meant!
Americium has a boiling point of 4,725 degrees Fahrenheit, or 2,607 degrees Celsius, a density of 12 grams centimeter cubed, and its heat of fusion is 14.39 joules a mole. Its atomic number is 95 and... wait. Then what does 241 mean? Oh, yeah. That's its atomic mass, which is 243 grams a mole. As the time of recording, the electronegativity according to Pauling is unknown. If any of you chemists know, please leave a comment down below. Here's what chemical changes it can undergo. As Britannica states, quote, Americium reacts with oxygen to form the dioxide AMO2, with the halogen elements to form the compounds such as the tetrafluoride AMF4, and all of the trihalidides with the hydrogen to form the hydride AMH, unquote. That explains why it's a crucial part of a smoke alarm, reacting with the air to measure smoke particles. But what about the bonds it can make? As previously said, Americium reacts with oxygen to form one of its chemical changes. According to Science Direct, Americium's common compounds are, quote, the oxide AMO2, fluoride AMF3, and oxalate AM2C2O43. Those are the most common compounds, unquote. These are pretty much all, unless you have more in mind. Americium falls under the category of antidides, which are radioactive and release energy upon radioactive decay. That explains why you should replace your smoke alarm every 10 years. Now, let's talk chemically here. It can react and form an element called AMH2, and that's it. Americium's solar mass is 141.1 grams a mole, which links back to the whole 241 thing. Since Americium is radioactive, let's move on to the nuclear side of things. There's many different isotopes for Americium, so here's a few. Americium-242M, with a half-life of 150 to 7,400 years. There's Americium-239, 244, 243, 247, 238, and 240, and Americium-241, which is radioactive and is used in ionization smoke alarms. Wait, if every alarm I have has 1 microcurie, and I have 80 of them. That's 80 Americium's half-life is between 432.2 and 7,370 years. Americium can undergo fusion, as explained before, and fission. This type of fission is called spontaneous fission. Now, let's get a little warmed up, shall we? Yeah, that wasn't very funny. Moving on, the specific heat value is 0.11 joules per gram for pretty much everything. And its heat of fusion value is 14.4 kilojoules a mole. And its heat of vaporization value is currently unknown. If you happen to know of a value, please let me know in the comments. And finally, let's move to acids and bases. Okay, I swear, this wasn't part of the script. I was just in the middle of editing this video, and I just realized as the time of recording, there's currently no data recorded for its acids, bases, liquids, or gases. So currently, this information is unknown. If you happen to know of any values, please let me know in the comments, and I will edit it into this video. Thank you very much. So that was all about Americium for you guys. I thought this was a pretty exciting experience to getting to research about an element that I'm pretty used to. But please don't expect content like this again anytime soon. So if you subscribe just because of this video, you really won't find anything else I post interesting. So until next time, this is Hydraulic 160, out.